So hello everyone, myself Rohit Kumar, and today I am discussing about the hierarchical clustering. I am a PhD student from Bennett University. Before discussing the hierarchical clustering, first we want to know that which topic I am going to discuss in the hierarchical clustering. So the first one is what is a cluster and the cluster analysis. The next, introduction about the clustering and its application. Then the classification of the clustering procedures and the good quality clustering and its approaches. The next is the hierarchical clustering methods, the various algorithms used in the hierarchical clustering. The next is time specific complexity and problem limitations and running. And then these topic I'm going to discuss. So first, what is a cluster? So basically the cluster is a collection of the data object. It may be similar, it may be unrelated or related. It depends which component we are going to make in the form of a cluster. So a cluster is a simple combination, and the cluster analysis is basically known various forms like clustering, data segmentation. So these are the cluster analysis techniques that we all are used in some areas. And the cluster analysis basically the finding similarity between the data according to the characteristic found in the data. So it's basic about the cluster analysis and the various application the clustering is using currently right now. In we can see clearly in the biology, the taxonomy of living things, the kingdom, the class, order, family, genus, species. The next is information retrieval, the document clustering, the various of document clustering. The clustering is using the land use, identification of areas of similar land. That is a observation of that which suppose a new industrial things are going to be happen in some areas. So land use, marketing, the city planning, earthquake studies, and the climate, about the climate, the earth climate, the finding the pattern of atmospheric and the ocean, and the economic sciences. So various application it is clustering is using. Next is quality. So what is a good clustering then? So a good clustering method with is basically some things that will make a clustering is good clustering. The first is the high intra-class similarity. So high intra-class similarity means that the cohesiveness and within the cluster should be high. Cohesiveness that the data point that are going to be making the cluster, there should be a cohesive. And the low interclass similarity. So low interclass similarity means that we can say distinctive between the clustering and the things should be low. And this is basically three parameter that makes a clustering things very good. The first one is similarity measure using by the method and the implementation, and the ability to discover some all of the hidden patterns. What type of hidden pattern it is using, that's make. So similarity measure, implementation, and the ability to discover of all the hidden patterns. That next of is classification of clustering procedures. So clustering procedure basically divided into two parts, the hierarchical and non-hierarchical. In the current presentation we will discuss only about the hierarchical part. So in the hierarchical we see the hierarchy. So agglomerative and the divisive, these are two type of hierarchical, and the agglomerative and part is further divided into three: the linkage, variance, and the centroid methods. And the variance method or the single method, Watt's method, but the linkage method can be divided further into three parts: single linkage, the complete linkage, and the average linkage. So we will discuss in the current presentation the hierarchical, agglomerative, divisive, linkage methods, Watt's method, and the single linkage, complete linkage, and average linkage. So various clustering approaches are we using in the uh, say research field. So the first one is the partitioning approach, that is a k-means or k-medoids and the clearance. So these methods are using in the past using partitioning approach. The next one is that we are going to discuss about the hierarchical approach, in which various methods, the Dyna, the Agnes, the Birch, the Chameleon. These are the methods. And the density based approach. The methods are the DB scan, the optics, the Deren clue, these type of density based method, but we are going to discuss about the hierarchical approach today in the current presentation. So the grid based approach is in the string, wave, cluster and link also. So clustering, if you talk about the clustering, so the main motivation behind the clustering is that the single clustering algorithm, if we talk about a single clustering algorithm, that may affected various factors, the noise, the outliers. So the k-means is very sensitive to this, sensitive to the distance matrices to find the best, the proper one, hard to decide a single best algorithm. So basically the main motivation of the hierarchical clustering is that we can it uh, distinguish best when we want to make a cluster using hierarchical clustering methods. So we will discuss the further that what is the main thing that make hierarchical clustering is the best clustering things. So as we discussed before, the hierarchical clustering is the methods where it's two type of the agglomerative and divisive. So basically the agglomerative clustering start with the each object is separate cluster. It means that this start with each object is a separate one, and the cluster that are formed by the grouping object into the bigger and bigger clusters. So a small cluster and then combine the two cluster on the basis of some distance matrices and then make a large cluster and then two combine with the adjacent and make a complete cluster. So this type of agglomeration. Divisive means that start with the big clusters and further divided and split until each object in a separate cluster until the some single outlier is divided into a single type of cluster. So basically, if we talk about the two methods in the agglomerative, so Agnes and Dyna. So Agnes is agglomerative and the divisive is Dyna analysis. So as clearly mentioned in this slide, that the step 1, step 0 to step 4, if we have the 5 object A, B, C, D, E and A or B, it's like a tree that A, B, C, D is a root and these are the branches and these are the leaf node A, B, C, D, E. So basically there are some operation D and D and multiplication operation D, E and the C comes further and the C, D, E and the C, D, E comes from the multiplication with A, B and A, B, C, D, E. So if we go about that in the forward in the right direction, that is step 0 to step 4, that is the agglomerative, the Agnes. And if you talk about the big cluster A, B, C, D, E and further divided into A, B and C, D, E and the C, D divided into C, D, E and D, E and further divided into single cluster, the leaf node cluster. The leaf node, not a leaf node cluster. Leaf node is a single outlier maybe into a single cluster. So that is a called dyna. So basically the Agnes and the dyna, these type of things we have. The next further we want to see that what is the Agnes agglomerative and the nesting. Basically the AGNES, this means the agglomerative nesting. AG for agglomerative and the nesting NES. So it's introduced by the Kaufman 1990, and in this is clearly mentioned that okay, in this we have seen the three clusters there and the three four are element outside the cluster, but again then this first cluster that a nearby point which have the nearest distance of this cluster and make the cluster of 3 2 3 2. So basically three cluster making the four cluster and every element is combined into this type of cluster and then further uh, divided into the four cluster, and these four are the basis of some distances then he find. And next is that this makes form a cluster that a 3 2. So 3 2 is basically form a big cluster and the 3 2 is basically form a next cluster. So it's basically the element and combine into a two clusters. So it's Agnes. The next is Dyna, the divisive analysis. It is introduced by the Kaufman same in 1990, but it's a reverse process as the Agnes. So in Agnes is clearly mentioned that it is made of two cluster, two large cluster, and then two large cluster is the input of this. So in this two large cluster into divided into four, and four into divided into the six different type of cluster. Each element, each further element that in the previous slide is there is clearly mentioned that three cluster and the two elements are there, but in this the last slide, two, and the every element, every single outlier is forming a cluster. So that is a, we can say, the good thing about this. There is a various distances that are calculated to find the various type of cluster: the single link, the complete link, the average centroid, the distance between the single link, the minimum distance between the two element, the complete link, the distance, the maximum distance between the two elements, the average means the average distance between the two elements from the one cluster to the another cluster, the centroid between the centroid of a two different type of cluster, the madoid with the distance of the madoid of the two clusters. Madoid is a chosen centrally located object in the cluster. So various type of distances that are that will be used in the further to understand the concept basically. Two methods we have discussed before. The first is Agnes and that's Dinah. The third one is a bitch. It's a balanced iterative reducing and the clustering using hierarchies. So it's basically uh, we can say the Jang Ramakrishna is the 1996 sigmoid, and it's basically the further we can say that a clustering feature. We first we make a incrementally construct a clustering feature, and the clustering feature is a tree that a hierarchical data structure for the multiple clustering. The phase one, the scan db into memory of cf tree, and then next is use this arbitrary clustering algorithm to cluster to a leaf node to the cf tree. So that is the bridge algorithm, and the final there is a weakness of this algorithm that only the handle the numerical data. So a data that is accepted beyond this numerical data, that is very sensitive or very hard to deal with this using bridge algorithm. So if we talk about that, what is a clustering feature and feature vector in the bridge? So first we understand that what is a clustering feature. So clustering feature is basically that about the uh, three type of clustering feature. We have the number of data point, the n, the ls, the linear sum of the data point, the sigma I 1 2 and 2 xi, and thus ss is a square sum of the points, so xi square from 1 to data point. So if we talk about the data point 3 and 4, 2 and 6, 4 and 5 and 4 and 7 and 3 and 8. So if CF is a 5 data points, so is the number of n is equal to 5, then ls is a linear sum, so sum of these x is 3 2 plus 2 plus 4 plus 4 plus 3 is 16, and then the y is same, the 4 plus 6 or 5 plus 7 plus 8, so it's 30. Then the square of this, the 3 3 the 9 plus 4 plus 16 plus 16 plus 3 is a 54, and then the 4 is square plus 6 is square, the 5 is square, 7 is square, 8 is square, it's a 54 comma 190. So it's a clustering feature, it's a clustering feature of the in the bridge. The next is the clustering feature. If we have many clustering features, CF1, CF2, CF3, and CF4, and this is beyond about the child 1, child 2, child 3, child 6. That is the known leaf node that are connected to the child CF1 and CF1. They have the two field, the previous and the next, and the next is connected to the previous of the next and next. That is the form, kind of linked list in the CF tree. So this type of uh, we can say that the phase 1 DB scan to build a memory CF tree, then uses this arbitrary clustering algorithm to cluster in a no-leaf node to make the CF tree. So it's basically about the bridge algorithm, so how we start this, and then next process, make a clustering feature, and then clustering feature and make it something type of tree and make a presentation of that. The next one is chameleon. So chameleon basically a data hierarchical clustering data model basically,